so I want to show this is the repository where I was working on the simulator and the finalization implementation. And one of the important things is that we need to visualize the DAG that we are finalizing, because without that, it's very difficult to understand what code is doing, and is it how we can we are progressing in good direction. So I want to show we were talking about the finalization fringes, because with multi-parent finalization, we are not finalizing only one block. We are finalizing the boundary or the layer, and so it's not just easy to imagine what exactly where this boundary is. And you probably seen our visualization with the graph viz, with which node can generate the source. So so for example, we can have things like that. But what I want to show today is the fringes, and what I did is I made some coloring on the same visualization graph, because the graph will support that. So you can see here in this very simple or very simple DAG, in a sense that all validators producing blocks at the same time. So we see here that each color represents a different finalization fringe. So if we are starting from the genesis as the first finalized block, which doesn't have to be, we are looking to simplify the Genesis ceremony, where we can apply the same logic even from the Genesis block. So here Genesis is finalized, and then each layer, and this is what we are calling the fringe, is finalized when the new blocks are built on top. So the last three layers cannot be finalized yet because they don't have enough stake. But you can see here how so what I didn't able to finish today is to mark which block finalizes which fringe. So for example, the block 04 can finalize the first fringe, this purple one. So I'm planning to include some kind of border of each block in the same color. So when you look at this DAG, you can immediately find out which block is referring to which fringe. So now I want to show little bit more complicated DAGs. So we can see here that even in this DAG, we cannot finalize even the first layer, because the network is splitted. So the layer doesn't have enough stake. But now when we have some merging of the branches, now we see the layer finalized. And if we have even more blocks, now we see how the fringe can be even if some node is a little bit late, when this node produces new blocks, this fringe becomes finalized. And maybe some little more complicated DAGs or longer DAGs. You can see here how these fringes are finalized. And they're in the sense they're equalizing, because even if some node is slower, he will have some gaps, but the faster node will have more blocks included in this fringe. So for example, here between this purple and pink, we have this white ones. And this just means that all of these white ones are included in the next fringe. So this node was a little bit faster, this was slower, and when the next layer was calculated, all of these blocks are finalized together with this pink one. And this is even more a longer DAG. And for example, this is even difficult to recognize what is going on, because this is something that we will have if we detect some strange situation with the DAG. We can generate the specific. So we are generating randomly. We are generating these DAGs, and even if we catch some bug in the future, we can store this randomly generated DAG in that moment, so that we can create the test from this specific DAG and include it in all future code. And even if we later, when we apply the fix, we want to be sure that we don't have some kind of regression bugs, and so we can replay all these specific tests. So this is one of these DAGs that we catch some bugs, and now it's included in the simulator. And you can see here how this DAG is very it's missing lots of blocks. So finalization is very difficult to achieve. So there is lots of blocks created, and there is no too many fringes. So this is probably something that we will not see in the real in the real network, but we can definitely simulate this kind of DAGs. And of course, all of this coloring will be we will include in the node code, and so any user can use it to generate and see the DAG. And this is all that I wanted to show. I hope it makes sense. Yeah, if there is some question.
Thank you, Tomislav. That was great. Really good. Did you have any other tech updates? Were there any other major efforts or things to report on the whole?
So I wanted to say that I hope that next week we will be able to connect the new finalizer with state merging, so that we can publish the first release on the testnet. So I cannot say that this will be that I'm completely sure, but we are definitely going into that direction, that we can do this for the next week.